Okay, now refer the second question. So here acceleration of the particle is given by a equal to kt square and unit is meter per second square. The condition given is it is found that v equal to minus 24 when t equal to 0 and v equal to 48 when t equal to 4 second. Also the position x is equal to 0 at t equal to 3 second. Then find the value of constant k and position, velocity and the acceleration at t equal to 2 second. Okay. Now the equation given is it is for acceleration, which is a equal to kt square. From the acceleration, the question is find out the velocity and find the position. Okay, means we have to go in a reverse way. So when we go in the reverse way, we have to integrate the equation. So observe the equation for acceleration a equal to kt square. The meaning is acceleration it is given as a function of time. Okay, so whenever acceleration is given as a function of time, means on the right side there is a time variable, then replace this value of acceleration a equal to, we have the equation, it is dv by dt. Okay, so basically we have two equations. The first equation a equal to dv by dt and second equation for a it is v into dv upon dx. Okay, so whenever acceleration it is given as a function of time, use this equation a equal to dv by dt. Okay, so replace the value of acceleration by this dv by dt. So this is equal to, it is kt square as it is. Okay, now take the dt on the right side. So dv equal to kt square into dt. Okay, now integrate both the sides. So integration dv, this is v, this is equal to k is a constant. Integration of t square will be, it is t cube upon 3. Okay, and we are integrating without any limit, so add the constant as a c1. Okay, now this is your basic equation for velocity. Okay, you can name this equation as equation 1. In this equation we have to find out the value of k and value of constant c1. Okay, so as there are two unknowns k and c1, we need two conditions. So the first condition is, refer the problem, v equal to minus 24 when t equal to 0. So right here, when t equal to 0, the v value, this is equal to minus 24. Put this condition in the equation 1. So v is minus 24. This is equal to, t value is 0. So it is k, this is 0 cube upon 3. So everything will be 0 plus c1. Okay, so we get the value of c1, this is equal to minus 24. Okay, now put the value of c1 again in the equation 1. So equation 1 becomes v equal to k t cube upon 3 minus 24. Okay, now use the second condition. So second condition is, refer this, velocity is 48 when time t equal to 4 second. So write t equal to 4, v equal to 48. Okay, so put this value in this equation. So put t equal to 4 and v equal to 48. So 48, this is equal to k 4 cube upon 3 minus 24. Okay, now if you solve this equation, then you can find out the value of k. So the value of k, this is equal to, this is 3.375. Okay, now put the value of c1 and the value of k in the equation 1, that is the basic equation of velocity. So v equal to k is a 3.375 into t cube upon 3 minus c1 is a 24. Okay, and if you simplify this, so 3.375 divided by 3, so v equal to 1.125 t cube minus 24. Okay, so this is the final equation of the velocity. Okay, you can consider this equation as a equation A. Now from the velocity, again we have to find out the position. So replace the value of v by the equation dx by dt, and then we have to integrate. Okay, so put the value here v. So from this equation, v is the dx by dt. This is equal to, write this as it is. So it is 1.125 t cube minus 24. Take the dt on the right side. So dx is equal to 1.125 t cube minus 24 into dt. Now integrate both the sides. So integration dx, this is equal to x, this is equal to, now integrate this complete equation. So integrate first term 1.125 t cube. So this is 1.125, integration of t cube will be, it is 3, so t raised to 4th divided by 4 minus 24t and plus the constant of integration, that is a c2. Okay, now to get the value of c2, one condition is given. X is 0 when t equal to 3 seconds. So consider this equation as a equation 2. Now use the condition when x equal to 0, t equal to 3 seconds. Okay, and put this condition in the equation 2. So from equation 2, x value is 0, so this is a 0. T value is 3, so it is 1.125 3 raised to 4th divided by 4 minus 24 into 4 plus the constant c2. Okay, and if you simplify this equation, then the value of c2, you can solve this equation, and c2 will be 49.22. Okay, now put the value of c2 again in the equation 2. So final equation for x, it becomes x is equal to this 1.125 divided by 4, this value will be 0.2813 t raised to 4 minus 24t and plus 49.22. So this is the final equation for the x. Okay, so consider this equation as a equation B. Okay, now we have all the equations. One is equation for acceleration, second equation is equation for velocity, and equation for position. Okay, now the question is we have to find out position, velocity and the acceleration at t equal to 2 seconds. So write at t equal to 2 seconds, the acceleration A is equal to k t square. So k is 3.375, so 3.375 into 2 square. So A is equal to, it is 13.5 meter per second square. Okay, so this is the first answer. Second, the velocity v equal to, now refer this equation, put the value of t as a 2 second. So it is 1.125 2 cube minus 24. So velocity is minus 15 meter per second. So this is the second answer. And third is x. So put the value of t as a 2 second in this equation, solve the equation. So finally x is equal to 5.721 meter. Okay, so this is how we can find out the velocity and the position if the acceleration is given. Okay, so always remember, if the acceleration is given, then we have to integrate so that we can find out the velocity, again integrate so that we can find out the position. Now refer the third problem. So here the acceleration is given a equal to minus 0.05 v square, and condition given is, knowing that velocity v is 20 meter per second at x is equal to 0, then find first position of the particle, means x, at v equal to 15 meter per second, and second the acceleration of the particle when x is equal to 50 meter. Okay, so write the given equation. So equation is a equal to minus 0.05 v square. Okay, now from the acceleration, our question is we have to find out the velocity equation. So from the acceleration we have to find out velocity. So whenever from acceleration we find out the velocity, we have to integrate the equation. Okay, so this is a reverse way. So replace this acceleration. Now observe, acceleration is function of velocity. So use the second equation of acceleration. We have the equation a equal to v into dv by dx. Okay, so why I have taken this equation? Because a is a function of velocity, not the function of time. If it is a function of time, just write a equal to dv upon dt. Okay, so put this value in the first equation. So v into dv by dx, this is equal to, just I am replacing the value of acceleration by this formula, v into dv by dx, this is equal to minus 0.05 v square. Okay, now use the variable separation. Okay, so take the velocity terms on one side. So it is v, take this v square into dv and take dx on the right side. So minus 0.05 into dx. Okay, v upon v square will be 1 upon v into dv, this is equal to minus 0.05 into dx. Okay, at this step integrate both the sides. Now integration 1 upon v dv, so 1 upon v integration will be log v, so this is log to the base e, this is equal to minus 0.05, it is the constant, so minus 0.05 integration dx, so it will be x, and plus the constant of integration as a c1. Okay, now this is the basic equation. So consider this equation as a equation 1. Now here we have to find out this constant c1. Okay, for that one condition is already given, v equal to 20, x equal to 0. So right here v equal to 20 and x equal to 0. Okay, so put the value, this is log to the base e, v is a 20, this is equal to minus 0.05, x value is a 0 plus c1. Okay, so the value of c1, this becomes log 20 . Okay, you can keep the value as it is, log 20, or you can find out the value of log 20 by using calcium. Okay, now put the value of C1 again in the equation 1. So it is log to the base e v, this is minus 0.05 x plus log to the base e 20. Okay, now you can take this log on the left side. Okay, so it becomes log to the base e, this is a minus, so we can write here v upon 20, because log v minus log 20, so we can write this as a fraction v upon 20. So this is equal to minus 0.05 into x. Okay, so this is the final equation of velocity in terms of position. So consider this equation as the equation A. Okay, now refer the question. Find the position of the particle when v equal to 15 meter per second. So this is the first question. So we have to find out position, it means x, when v equal to 15 meter per second. Okay, so put the value of v as a 15 in the equation A. So this is log to the base e, v is a 15, this is equal to minus 0.05 into x. Okay, so if you solve this, then this log e 15 upon 20, this value is a minus 0.287, this is equal to minus 0.05 x, and from the x is 5.75 meter. Okay, so this is the first answer. The second question is, we have to find out what is the acceleration, means value of a, when x equal to 50 meter. Okay, but if you refer the first equation, the acceleration is purely depending on the velocity. There is no term of the position. Okay, but the position term x, it is present in the equation of velocity. Okay, so first we will find out the velocity when x is equal to 50. So first we will find out what is the velocity when x is a 50. Okay, and then put this velocity in the equation of acceleration. Okay, now use the equation A. So it is log to the base e, v upon 20, this is equal to minus 0.05, x is a 50, so this is equal to this is minus 2.5, and this is log to the base e, v upon 20. Okay, to cancel out this log, take the e to the power on the right side, so we can write here v upon 20, this is equal to e raised to minus 2.5. Okay, so in the calculate this e raised to minus 2.5. So this value is 0.082, so this is v upon 20, and from this find out v. So this is 1.64 or 642 meter per second. Okay, so this is the velocity when x is equal to 50 meter. Now we have to find out what is the acceleration. Now for the acceleration, a equal to minus 0.05 v square, and put the value of v as 1.64. So this is minus 0.05 1.642 square. So acceleration, this is minus 0.1348, and unit is meter per second square. Okay, so if the equation of acceleration, it is given as a function of v, then use the formula a equal to v into dv by dx. Replace this acceleration by that formula, and then use the variable separation. Okay, and then integrate the equation. we will get the equation for velocity. Now refer this fourth problem. So the condition given is acceleration of the particle is given by the equation a equal to 100 minus 3x square. At t equal to 0, v is 0 and x is also 0. Then find, first question is at what position velocity is 0, means we have to find out the x when v is 0. Second question, velocity of the particle at x is equal to 8 meter. And the last question is at what position particle acquires maximum velocity. Okay, so write the given equation, which is a equal to, it is 100 minus 3x square. Now see the equation on the right side. So here acceleration, it is a function of x. So whenever acceleration is a function of x or v, replace this acceleration by the equation v into dv upon dx, and this is equal to 100 minus 3x square. Okay, now try to separate out the variables. So just take the dx on the right side. So it is v into dv, this is equal to 100 minus 3x square into dx. Okay, now integrate both the sides. So take the integration. So v dv, its integration will be v square by 2, means integration of v square by 2, integration of 100 into dx. So I will write like this, 100 into dx minus integration 3x square into dx. Okay, so this is 100 dx, means 100 is a constant, so it is 100 into x, integration of dx, minus 3 is a constant, x square integration will be x cube upon 3, and plus the constant of integration as a c1. So this is v square by 2. Now this is the basic equation after integration, so consider this equation as a 1. Now we have to find out this constant c1. For that, one condition is given, t is 0, v 0 and x 0. Okay, now in this equation there is no time term, so just write x is 0 as it is given, v is 0. So if you put v 0, x is 0, x is 0, so everything will become 0. It means the constant c1, this value is 0. Okay, now put the value of c1 again in the equation 1. So this is a 0. So final equation of velocity, v square by 2, this is equal to 100x 3 by 3, 1, so minus x cube. Okay, so this is the equation for velocity and the position. So this is your equation A. Now refer what is the question. The first question is at what position velocity is a 0. Okay, so it means that in the first question we have to find out x, means position where velocity will become 0. Okay, so put the value of v 0. So left side is a 0. This is equal to 100 x minus x cube. Okay, so from this you can write here, this is 0, you can take x common, so x in the bracket 100 minus x square. Okay, so first equation will be x is equal to 0. So x is 0, and the second equation will be 100 minus x square, this is equal to 0. So you can take x square on the right side. So from this x square is equal to 100 and x is equal to plus or minus 10. Okay, so this is the answer. The meaning is velocity will be 0 at 3 different positions, one x 0, second x plus 10 and third x minus 10. Okay, now refer the second question. In the second question velocity at x is equal to 8 meter. Means we have to find out the velocity of the particle when the position is x equal to 8 meter. So this is a straightforward. Just put the value of x 8 meter and find out the velocity. So this is v square by 2, this is equal to 100, x is a 8 minus 8 cube. Okay, so if you simplify this equation, you will get the value of v. So this is plus or minus 24 meter per second. Okay, it means that at x is equal to 8 meter, particle will have the velocity either plus 24 or minus 24. Okay, because here we have the v square. So if you take the square root, two values are possible, plus and minus. And the third question, at what position particle acquires maximum velocity? So always remember, for maximum velocity, there is a condition, acceleration it must be 0. So whenever particle's acceleration becomes 0, particle will have the maximum velocity. Okay. So now refer the acceleration equation, it is already given. So in this equation, a equal to 100 minus 3x square, put the a as a 0 and from this find out the x value. So if you find out x, so x value is 5.774 meter. Okay, even we can take the negative value. So just I am giving the answer for positive. So plus 5.774 and put the value of x in the equation of velocity. So we have this equation for velocity. Okay, so this is v square by 2, this is equal to 100 5.774 minus, and from this find out the velocity. So here v, it is 27.74 meter per second. Okay, so this is the maximum velocity. So this is a v max. So condition is, for maximum velocity, acceleration of the particle, it will be 0. Okay, so put the value of acceleration 0 in the given equation of acceleration. From this find out x, and then from the x find out this velocity. Now refer this next question. So the question is, a particle starts from the rest, from the origin, and its acceleration is given by a equal to k upon x plus 4 bracket square. Knowing that v equal to 4 meter per second when x is equal to 8 meter, then find the value of constant k and also calculate the velocity when displacement is 10 meter. Okay, so first write the given equation, a equal to k upon x plus 4 bracket square. So this is the given equation. Now replace this a by the equation v into dv upon dx, because on the right side of acceleration there is a term x. Okay, this is equal to k upon x plus 4 bracket square. Now take the dx on the right side. So this is the variable separation. So v into dv, this is equal to k upon x plus 4 bracket square into dx. Okay, now before integrating this equation, take this denominator term x plus 4 bracket square in the numerator. So this is equal to k x plus 4 raised to minus 2 into dx, and this is v dv. Okay, now integrate the equation. So integration of v will be v square upon 2, this is equal to k is a constant, integration of x plus 4 raised to minus 2. So we can integrate this, x square integration is x square plus 1 upon 2 plus 1. Okay, so same x plus 4 minus 2 plus 1. So this is basically n. So n plus 1 divided by n plus 1. So minus 2 plus 1 and plus constant of integration, that is a c1. Okay, so simplify this equation. So v square upon 2, this is equal to k x plus 4 minus 2 plus 1 minus 1 divided by minus 1 plus c1. Okay, so we can minus 1 take this v square by 2. I can write here minus k upon x plus 4 raised to minus 1, we can write in the denominator as a x plus 4 and plus the constant as a c1. Okay, now this is the basic equation. So consider this equation as a or equation 1. Now here we have to find out this constant c1. For that there are two conditions. The first condition is particle starts from the rest from the origin. Okay, so the meaning is when the particle starts from the rest, its velocity is 0 and from the origin means x is equal to 0. So this is the first condition. Put this condition in the equation A. So v is 0, this is equal to x is 0, so minus k into 1 upon x0 means 1 upon 4 plus c1. Okay, and from this we can write c1 is equal to minus k by 4, on the left side will become k by 4. Okay, now put the value again in the equation A. So equation A we can write v square by 2, this is equal to minus k upon x plus 4 plus c1 value is a k upon 4. Okay, so you can consider this equation as a equation B. This is not the final equation, we have to find out the value of k. Now refer the second condition. So in the second condition, this v, it is equal to 4 meter per second when x equal to 8 meter. Okay, so v, this is equal to 4 meter per second when x equal to 8 meter. So put the value of v and x again in this equation. So v is 4, so this is 4 square by 2, this is equal to minus k, x value is 8, so it is 8 plus 4 plus k upon 4. Okay, now try to simplify this equation. 4 square 16 by 2, so this is 8 minus k upon 12 plus k upon 4. Okay, so this is 8, just multiply here by 3. Okay, so minus k upon 12 plus 3k, 4 into 3 12, so this is equal to 3k minus k, so this is 2k upon 12, this is 8, so this is 6 and k is equal to 8 into 6, so this is 48. Okay, so this was the first question, that is to find the value of k. Okay, now put the value of k in this equation, that is equation B. So from equation B we get the final equation for velocity, v square by 2, this is equal to minus 48 upon x plus 4 plus 48 upon 4. Okay, so this is v square by 2 minus 48 x plus 4 plus 12. So this is the final equation for velocity. Now refer the last question. We have to find out the velocity when x is equal to 10 meter, means displacement or the position is 10 meter. Okay, so put the value in the equation. C, which is the final equation. So v square by 2, this is equal to minus 48 upon x is 10 plus 4 plus 12. Okay, so you can simplify this equation and then get the value for v. So here v square by 2, this is equal to 8.57 and v square is equal to, this is 17.14 and v equal to 4.14 meter per second. So this is the final answer. Okay, so the question was, the first question, find the value of k and also calculate the velocity when displacement is 10 meter. Okay, so value of k is 48 and the velocity is 4.14 when displacement or the position is 10 meter.